second circle video from sections 3 and 4 in chapter 10 on chord problems and inscribed angles. I think it'd be a really good idea for you to take out a piece of paper and try these problems right ahead of me. Pause the video, give them a try, and then see how to work them afterwards. Much more learning happens when you're doing it yourself. So the first problem is a chord problem, and we talked in class about our goal is to always create a right triangle whenever possible, because that way we can use Pythagorean theorem, 30, 60, 90s, 45, 40s, or triples. So here we're told the diameter of a circle is 12. Find the length of a chord that is 5 inches from the center. So this is definitely one of those chord problems. Always we draw it the same way. We're going to have a chord to a circle. We're going to have the distance from the center. Make sure this is perpendicular, this distance from the center, and we'll draw a radius always to make the hypotenuse of a right triangle. So they didn't give us the radius, but they did give us the diameter. So if the diameter is 12, the radius will of course be 6. And notice the chord's not 5, the distance from the center is 5, so that is here. We want to find the length of the whole chord. So this is not a triple, unfortunately, but we can always use Pythagorean theorem. I call that a squared plus 5 squared equals 6 squared. So a squared plus 25 equals 36. And if I subtract my 25, a squared equals 11. So a is the square root of 11. Now be careful. They did not ask us to find just this a. They asked us for the length of the chord. So make sure when you're asked for the chord that you double it to get the whole thing. So our chord length will be 2 times root 11. Okay, second problem here. Pause it if you want to try it first. Find the measure of all the arcs and angles. This is one of my favorite types of problems. I can put in any numbers and we should be able to find everything on here. So notice the center is here, so none of these angles in the middle are central angles. But we do know inscribed angles are equal to half of the arcs they open up to. So find an angle whose vertex is on the circle, and know that it will be half of the arc it opens up to. So this angle right here is half of 102, 51. What other angle opens up to 102? Well, it looks to me like this angle does. Vertex is on the circle, so this is 51. Now notice I can't use this angle. Its vertex is not on the center, and it's not on the circle, so it's not an inscribed angle, it's not a central angle, so I can only find these angles in the middle using triangles at the end. So maybe I can use my angles and go backwards. This angle opens up to this arc, so the arc must be twice the angle. If this is 53, double it, that arc is 106. Looking good. Okay, this angle opens up to this arc. So the arc is the bigger part, twice the angle. If that is 40, this will be 80. Now I'm kind of stuck a little bit, but I can follow back my arcs that I now have and see what other angles open up to them. If I follow this back, this opens to 80. So just look at one angle at a time, see what it opens up to. So that's 40. This angle opens up to that top arc. I don't have that top arc yet, but I can get it. I have 102, 106, and 80. So that's 208 plus 80, 288, and I know in the circle is a total of 360 degrees. So I can subtract that to get that top arc, which would be 72. So if this is 72, then I can follow back the angles that open to that. This would be half of 72, 36. This angle opens up, is half of 72 is 36. What else do I have left? This angle, what does it open to? Follow that angle, opens up to the 106. Make sure you're looking at the numbers on the arcs, not looking at what it opens up to as other angles. It opens up to the arc 106. So this is 53. So I have all these out outside angles. Now I can find the middle ones if I want to. Just subtract from 180, 53, and 36. Is that right? Yes, 53 and 36 is 89. So subtract that from 180. So this would be 89. And this would be 91, 91, 89. All these linear pairs and vertical angles like we've always done. And so we found everything in the figure. Okay, this next problem. Another thing we learned by knowing inscribed angles, since this angle is half of all of this, and this inscribed angle is half of the rest of the circle, together they're half of 360 degrees. So this must be 63 because opposite angles in a quadrilateral that is inscribed in a circle have to add to 180 to make those inscribed angles equal. Now we don't know anything about these two angles. We weren't given enough information to find those, but we know this one has to be 63 because 63 plus 117 is 180. The other theorem we know about inscribed angles is that if an inscribed angle opens to a diameter, if you see that big dot, then it is 90. So this angle opens up to a diameter, so that is 90. This angle too opens up to a diameter, so it is 90. Then I can use my inscribed angles. Angle 3 opens up to the arc 70, so it is half of 70, 35. So angle 4, I could use my right triangle and add everything to 180, meaning these two would have to add to 90, so that would be 55. And if I wanted this arc, it is twice 55. That opens up and it's 110. I could also get that arc because I know this is semicircle, so 70 and 110 have to add up to 180. So on this side, I've got a right angle here. Angle 1 opens up to 60, so that has to be 30. Since this is a right triangle, if that's 30, this is 60. 60 opens up to this arc, so that arc is twice 120. So this figure here we've seen a couple times already. So pause the video and see if you can get through it. But a couple things we're going to keep in mind. Parallel lines cut equal arcs between them. So if this is 112, I immediately know this is 112 degrees. Also, central angles are equal to the arcs that they open up to, but I don't have that arc yet. But since I have 112 and 112 and 60, I can add those to 360 and subtract 360 minus 112 minus 112 minus the 60, and that gives me 76 degrees. So this arc up here must be 76, and therefore the arc on the center, P there, is also 76. Now you can't use that for Q. All these angles are not central angles and they're not inscribed. The only way you can find these angles right now is to use triangles, 180 degrees. So we need to find some more angles. So I look at one angle, just find any angle. This angle here, it is definitely inscribed. The vertex is on the circle. What does it open to? It opens up to 112 degrees. That's the arc. So it is half of 112, 56. This angle also opens up to 112 degrees, 56. Now I could find my angle here by using the triangle. 56 and 56 is 112. Subtract that from 180 gives me this is 68. So that would be 68. And the linear pair would be 112. What about this angle? What does it open up to? Inscribed angle opens up to the arc 76. Make sure you're looking at the arc that it opens up to, not the other angles. So half of 76 would be 38. This angle here, BDA, also opens up to 76. So it's 38. How about this angle? Angle PAC follow it to an arc opens up to 60, so it is 30. CBD also opens up to 60, so it is 30. Now the trickiest ones on here are all these top angles. Know that equal radii, all radii are equal. So if you notice that these are both radii, you know that they're equal, and therefore we have an isosceles triangle. So we can do 180 minus the 76, divide by 2, so that's 104 divided by 2 gives me 52 of these two base angles for the isosceles. Now how about this big angle here? I kind of got to find the big angle before I can find the little small angle. This angle, BAD here, BAD, open up to that big 112. So that big angle there is 56. So if that's 56, I'm going to write it out here, and this is 52, this must be 4 degrees when we subtract them, so the little angle's 4. 52 plus 4 degrees, same thing over here, would equal the 56. And now we have all the angles and the arcs from this figure. Last one, we had this one in class. Good one to go back over before your quiz. Find AB. We have a chord here that we're trying to find the length of. Again, try to draw a right triangle whenever you don't have one. So I would cut that into a right triangle. When a radius is perpendicular to a chord, we know it cuts it in half. And we know it cuts the arc in half. So if that was 120, we now have 60 degrees and 60 degrees. A central angle is equal to the arc it opens up to. So angle C up here has to be 60 degrees. So I've got this 30, 60, 90 triangle. Write in your formula, make sure you use it correctly. Hypotenuse of a 30, 60, 90 is 2x. Across from the 30 is x. Across from the 60 is x root 3. So if 2x is 8, my x would have to be 4. And my x root 3 is now 4 root 3. But I was asked to find the length of AB. So 4 root 3 here plus 4 root 3 here would be 8 root 3 for my final answer. I hope this helps. Make sure you check your answers on your review sheets, start it early, and come ask me questions if you need help before your quiz.